My name is David Heldebrant, and I'm a senior research scientist at the Pacific Northwest National Lab, and I work on clean fossil energy. Clean fossil energy is the ability to produce power from fossil fuels with having minimal acid gas or greenhouse gas emissions. Carbon emissions come from any time you combust a natural fossil fuel, whether it be petroleum, whether it be coal, whether it be natural gas, or even biomass. Anytime you burn these materials, you're going to be emitting CO2 into the atmosphere. And examples of this could be any time you fire up your barbecue, every time that you start your lawnmower, or even drive your car, you're going to be contributing CO2 into the atmosphere. The place that you find carbon dioxide is in what is known as flue gas, where it's essentially a giant exhaust pipe for these giant coal-fired power plants, and all of that waste gas is coming out of the top of it. And so what they do is they divert that gas stream into this giant absorbing column where you have liquid cascading down from the top and the gas coming back up the other way, and they kind of intermingle with each other, and the gas gets separated. Then you take your liquid out into a separate column where you heat it up, and all that carbon dioxide is kicked off and it's clean, and then you recycle your liquid, and the whole process then continues further. And so then you have your clean gas coming out of the top of what is called the flue now, where it's essentially just purified air. There are current technologies that are available to pull CO2 out of these large-scale flue gas stacks, but at the same time they're very energy intensive, which means they drop the overall efficiency of a power plant often up to 20%. And so when the industry is making less power, they're obviously going to increase the rate of electricity on the average American consumer, so ultimately the cost is brought down to the American public. And so here at PNNL, what we're trying to do is to be able to come up with a more efficient process that will actually improve the efficiency of the capture and therefore allow industry to make more product and therefore result in a more acceptable cost increase to the American consumer to have clean air. Well, we hope to be able to approach all areas of this, first being for the environment, because a lot of these impacts of climate change we're not going to see in our lifetimes, and obviously it'll be generations down the road. So we want to make sure that we're leaving a good legacy for them. Second of all, we want to be able to not put this burden solely on industry because, they're making power for us. We'd like to be able to improve their efficiency, so therefore they're not paying this price themselves. But lastly, we'd like to make sure that it's efficient enough that the American consumer is ultimately not placed with this huge price tag. And so it can therefore be acceptable and cheap and efficient electricity. My name is David Heldebrant. I'm a senior research scientist at the Pacific Northwest National Lab, and I'm making clean fossil energy a reality to fight climate change.